Here in Scotland and around the world, people think of three types of projectiles: objects thrown straight down, objects thrown straight up, and the most common, objects thrown at an angle, making a parabolic shape. This parabolic curve can be broken down into vertical and horizontal vectors to determine the projectile's velocity. Projectile motion is important to me, to my people, because we are a people of war. As we go into battle, we need to know how our arrows will travel, and at which angle to shoot them so we can penetrate the enemy's defenses. We determine this with a complementary angle mechanic. For example, if I'm shooting at a 15-degree angle, but the enemy has a wall of shields protecting them, then I can shoot the arrow at a 75-degree angle, get around the wall, since it will travel the same distance at either angle. I guess that about will does it for us. Thanks time for you to take a trip into the future about 700 years and get to London. Well, I'd better be off.
Here in London, us guys need to know a little bit about projectile motion. To keep up with security, we need to know how a gun shoots and how a bullet behaves, since it is a projectile. If I were to shoot this gun right now, the bullet would travel horizontally and vertically. However, these two perpendicular vectors exist independent of one another. To find the vertical displacement of a projectile, you use this formula. To get the horizontal displacement, you use this formula. Remember, the horizontal velocity remains constant throughout. To prove that these are independent of each other, I did a little experiment. I took this gun and I shot a bullet straight out, parallel to the ground. At that exact second, I dropped a second bullet from the end of the barrel. Then I watched as both bullets hit the ground at the very same time, although the one I shot went much further than the one I dropped. People often ask us why we carry these big rifles around and don't swap it for a more portable pistol like this. Well, each option has its own strengths. The shorter barreled pistol is a smaller and more portable option. However, the long barrel on the rifle gives the bullet added accuracy, since it has a longer barrel for the projectile to travel through, as well as added velocity, since the energy from the gunpowder is only acting upon the bullet while it is in the barrel of the gun. We up here in Brickfilm would rather give up portability for accuracy and velocity. To hit a target that is an equal height as the initial position of the projectile, you need to aim the projectile above its horizontal so that it does not miss the target low or hit the ground before it reaches. To find the angle to aim it at, use this equation, where a is the magnitude or velocity of the vector, x is the distance between the projectile target, and theta is the angle. Now let's travel back in time to a great civilization that was more advanced in mathematics and physics than anyone else in the world at the time, the Mayans. When we talk about projectiles being thrown straight up or straight down, there is not much to calculate since there is no horizontal displacement at all. If you want to find the maximum height of the projectile, take a formula for the horizontal vector and solve for y. Granted, you have the initial velocity of the projectile, since the final velocity would be equal to 0 and g would be equal to the force of gravity constant. Similarly, if you are looking for the time, plug into a different formula and solve for t, assuming that the initial velocity is given and that the final velocity is the negative of the initial velocity. To calculate the time it takes for an object to be thrown straight down to hit the ground, solve for the formula for t, provided that you know the initial velocity and the distance the object is from the ground. To find the distance down, simply solve for y if you are given the initial velocity. Eso fue fácil, ¿verdad? Now it's time to head up to the North Country to meet some people who can help you understand an additional physics topic related to projectile motion. Free fall.
Hello there. Since we Vikings are a people with slightly less use for projectile motion than the others you met today, we want to talk to you a little bit about freefall. Although many people think we're a moving settlement only concerned with pillaging, plundering, and leaving, that's not the entire truth. We also have a home that we protect very well. We usually fortify on cliffs so we have a height advantage over our enemies. Our favorite tools for defense are boulders that we drop off the cliffs onto the disadvantaged foes. To know how often to drop these boulders, since we usually like to wait for the one before to hit the ground before the next one goes over, we use the physics of freefall, since the boulders are not thrown with any initial velocity, and are just aided by the force of gravity. These equations are used to determine the velocity, time, or distance an object travels while in freefall. And that's basically it. We've all had a blast informing you about projectile motion and freefall.